what should we be linking if we, oh, there we go. When we see common ratio, what does that get linked to? What does that language mean we're going to be looking at? Go ahead. Yeah, this means right here that I'm looking at a geosequence. Is that debatable that it's a geosequence? Yes or no? Why does it make the next step easier then? If it's not up for debate that this is a geometric sequence, why is the next step then easier than it perhaps could be? Yeah? How many times did we normally make you do that? How many times? On a geoprogression, how many times did we say find the common ratio, or how many times did we have to show in order to verify it was a common ratio? How many? 2. If it's telling you it's geometric, that means it's not up for debate, which means you only need to find it once. And it should be the same throughout that. So how would we go about finding what our common ratio is? Alexa, what do you say? Which is? I get so irritated by a lot of things. But this in particular, you're on the exam, you resort to your, as studies show conclusively, in a pressure environment, and the more unfamiliar you are, the more pressure you're obviously going to feel, you revert to your primitive brain. How are we going to go through and do this division? You tell me. We're going to make this so easy on ourselves. You've got 2 fractions that are divided by each other. How are we going to get what that comes out to be? You're sitting there in June. You're in the cafeteria. You're obviously in all black, and you're part of the Army. What do you want to say? Just doing too much. Yeah. Thank you. Control division, and in your numerator you do control division. So, by the way, sign in if you haven't already. Now, are you wrong for going through and saying you multiply by the reciprocal instead of dividing? No. But on an exam, are you going to want to waste? You're probably going to be so excited and so nervous. I don't want you to screw it up. You can't do the A's and the B's in the calculator, but you sure can go through and do those divisions. So, Robbie, what do you get when you do the division, and what's left when you do the division of the fractions, and where? Okay. What do you get when you divide this over this, and where is it going? What's that? You said it with a little hint of a question. What is -6 as a fraction? No, what is it? -6 over 1. So if you need to put the 1 down here, you can. Okay? But that's how you know. Think it's telling you what the answer is in simplest form. If it needed a fraction, you could go through and do that. Let's go through now and handle the next part. Abby, do you want to do the A's or the B's? Okay. What's left when you do the division by B, and where is it? Inappropriate language. Can you imagine that? If I wrote, who's your VP? Do you know? Who is? Does anybody know? Who's got M? Who knows their VP's name? Who is it? No, it's not here. Who knows who it is? Oh, so maybe it's straight. Okay, I'm going to write you up. Straight. We're walking together. Stand up. What is it? M said something vile, I mean profoundly inappropriate, questionable language, and he's going to go, "What is it?" And I'm going to say, "Abby, you tell him." What's she going to say? And he's going to look at me like I'm the biggest moron on the face of the earth. He's going to think I'm nuts. He's going to ship me off to some sanitarium. They probably already want to, right? This will be what sends them over the edge. Now, let's do it with the A's. And Jared, what's left with the A's and where? There you go. Just an A squared in that denominator. That's your answer. Questions on that? Outstanding job. Can you check this in the calculator? Can you? You can do the fractions, not the whole thing. This next one, we can guarantee what our answer is correct. Meaning, no excuses. No excuses. Maybe we'll have to introduce a new person, the NSOLVE Ninja. And he can go through and attack you if you don't check your answers using NSOLVE. Looking at what's there, how am I going to get an answer for the next? And notice it says algebraically, which means no guess and check here, none of that. By the way, just so you know, guess and check doesn't exist, is not math, doesn't do anything. Stop trying, give it up. It's done. No guess and check. If you have dullards who have taught you in the past and told you that's okay, understand, when we grade, it makes me want to stab my eyes. It shows you know nothing about math. Like literally, it's like, if I had gone to the dog, and I said, what's the number I want to try in this? He's like, 1. Like, that's how clueless it appears. That's not math. Is that clear? What are we going to go through and do? And answer the next one. What would you write out? Outstanding. From here now, this is me getting you ready for pre-calc. Looking at what you have, what does this exponent mean? Hands up when you can answer that. What does that power mean? Not what is it. What does it mean? What?
Root 27 power.
This is your power. This is your root. If I took the calculator away from you, which one would you evaluate out first? Would you take the 4th power of 27 or the 3rd root of 27? Which one?
Third root.
What's the 3rd root of 27? 3. Now I need to take that and raise it to the 4th power without a calculator. Alex, what's 3 to the 4th power going to give you? 3 times 3? Times 3? Times 3? 81. 2x minus 1. What do you do now from here, Alexis?
Then you add the 1, so 82 equals 2x.
Go in right now and check that using NSOLVE. Every one of you. Does it work, yes or no? It absolutely does. Can you understand my frustration when you don't get the right answer? Can you? Do you wonder why I yell? I can't even get people to push the calculators all the way to the in the thing, much less get these questions right. Check your answer. That's too far. I'd rather get it wrong. I tried really hard on that exam, but I got 14. I have one that I'm working with down in Gold, and this is so tricky. I'm so excited. We're trying to get her through the L1 exam. I'm not even going over math. You know what I'm showing you how to do? I bet you I can get somebody through that exam who doesn't know the math. I can almost guarantee it. Why? You're trying to figure out what's equivalent. Go to that equal to equal, press enter. If it's equal, guess what it says? True. And if it's not, guess what it says? Well, that's difficult, right? It's a keyboarding test. What is it that you take? Was it, it's not keep typing, word processing. This should be, your Algebra 2 region should be your word processing fine. Take a look at the next one. How many answers is this going to have, Jessica? What would you do to start this off? So I've got x to the 4th plus 4x cubed plus 4x squared plus 16x is equal to 0. What do we do now from here? Leah? We could. I see something I want to do first, though. You're still going to get the right answer. It's going to require a little bit. Actually, you know what? We'll do it by group. We'll do it. What? Oh, no. We won't for a reason. You'll see why in a minute. Perfect. Outstanding. Take out a GCF of x. That leaves me with x to the 3rd plus 4x squared plus 4x plus 16 is equal to 0. Now I look at what I have there. What do I do to go forward from here, Nick?
Backbreaker.
Yeah, so now, notice I keep the x on the outside. I'm going to have secondary parentheses, so I use brackets. What can I factor out from the first two, Nick?
X squared.
And what's left?
X plus 4.
Now look at the next two. Luke, what can you take out there? What kind of form? What's left? Now, we can still factor, you're not going to want to hear this because some of you don't make this linkage. You can still factor this more. Look at the expression on the inside, and hands up please when you can tell me what type of factoring you can do on this. Hold on. What type of factoring can we do on this? Look at what's there. The easiest one to do. It stares you right. It stares you down. And you're the one who always blinks first. That's just a big awkward binomial with binomial components. No one knows what kind of factoring we can do on that? What type of factoring? Look at the left half of the binomial and the right half of the binomial. What do the left half and the right half of this green binomial share? What do they both have? An x plus 4, a common factor, yeah. So I take the x out still. I take out an x plus 4, which they both share, and then what's left then? X squared plus 4. Now you're going to get there the same way, but I want you to know why that works. What do we do once we get to this stage? Oh, we just got Hannah. Then what happens from here? What's that? We already factored. You can't factor anymore. How? No? You said, see, we're using our words. I'm so proud of you. We're going to grow up. X equals 0. First factor set equal to 0, and that's an answer. X plus 4 equals 0. And x squared plus 4 equals 0. And there's a temptation there to think that that factors down. What do you say to those who would argue that x squared plus 4 factors down? What are you going to say to them? What? You're outraged and offended. Sure. I'm technically by now I think actually I'm just living in a state of perpetual outrage. Why would you be outraged and offended if they try to do that? The factor pattern is called difference of perfect squares. Normally, difference means what math operation? Does difference ever mean adding? No. X is equal to negative 4, and then over here, we bring this over, x squared is equal to negative 4. What do we do, Maddie, from here? And what are you going to give, please? What's that? Now, how can you guarantee you get this right? Did we show you poly roots? Everyone right now is going to go into their calculator. Sign in if you haven't already. We got 3 of us, 2 of us who haven't signed in yet. And everybody right now is going to go to, oh, all right, well, I'll show you this. Whomever this is did a great job while they were here, while they were probably waiting for the rest of us. Do all of these work? And the answer is yes. That's one way to check. If this were a multiple choicer, I would argue you don't need to do anything. I would go into menu, go into algebra, and there should be a thing in there that says poly tools, which you're going to select, and then you're going to go down to poly roots. Now, no, not end solve. Go back, menu, 3. I think it's 3, 3, right? Yeah, 3 again. Now, it says find the roots. What I need you to do is this. You're always on the lookout for imaginary answers, every time. So always pick complex roots. No. Oh, sorry. Just if you go back and delete that end solve in front, it'll go away. Okay? Now go over to poly roots, and I need you to plug in the equation, the original equation, comma x. Careful. I don't think that's the original, is it? There's a 4 there, I thought. put comma x. Tell it what to solve for. Oh, sorry, never mind. You don't need the comma x. What a dummy. What is this? Error variable is not defined. What's that? Plus 16x. Take out the equal. So what is it saying? I'm sorry. Do you just do plus 16x and then comma x? Okay, sorry. See, these tools are new for me as well. So you put in your polynomial and tell it, okay, what does it show you? If you've set your poly equation to be equal to 0, you know what it's doing right now? It's putting in, so I thought you could do it with the equation. You have my apologies, you can't. What it's asking you to do is put in the y equals polynomial and tell me what variables, when the x-intercepts that it's looking to solve for. How many answers did it list out? 4. Are you kidding me? Are you kidding me? Get real. So easy. They make it for you. So easy. Now, we're going to start off with this. And actually, I think maybe we can do, I think I still have this solved. So go into your calculators, have your notes out. This shouldn't take 30 seconds, and it doesn't require any conversation. What we are, oh, the thing shut down, that's why. Go through, make sure your notes are out. And you got the video the other day, right, on how to get to the end? How long was that video? I think I fast-forwarded to the right spot. It was like 6 minutes or something. Okay. So, let's see, documents, tools. We're going to do this quickly. Custom choices, yeah. So, answer this question right now quickly. And we have 24 of you signed in, which means I need 24 answers. We've got 16, 20. This is not, the questions do get tougher in here. We're at 22. Still at 22. 23. Oh, 22. 23. So close. Why are we always one short? Oh, no, we're at 23 still. Don't fight the man. All right, well, you see why sometimes I get angry? We've got 20, literally all you have to do is click one of the choices. Somehow, and I'm going to find a way to survey and know who it is, and we will we'll yell at them for shame as they walk through the halls. Now, looking at this grouping, so as of right now, we're going to use this as our data. Just so you know, we've got 23 total persons in this class that voted, and 11 picked blue. So let's answer this out of our class. What's the probability that a person's favorite color is blue? Hands up, please, when you can answer that. Based on our class, what's the probability that a person's favorite color is blue? You just saw it, and we discussed the data. This should be easy for you. What? 11 out of 23. Next one up. Now, you're silently going to do this, which means it requires negative talking. Go through, survey the room with your eyes. You might find new people you haven't met before. You're going to answer question B, and hands up when you can give me an answer to question B. Look around. No talking is required. Hands up, please. Don't forget about yourself. Hands up, please, when you can tell me the answer for question B. Got no one that can tell me what's the answer to this question going to be. Seriously, 3 people? They do get tougher when we're doing this. They do get tougher. Got 1, 2, 3, 4. I can count. They really count. Now, next one up. Person chosen is female. What's the probability that her favorite color is going to be blue? Now, what I need you to do is this. Those 11 of you, do not modify your answer. There were 11 people who selected blue as their favorite color. What I need you all to do right now is, if you picked, for everyone, if you picked blue as your favorite color, I need you to go through and raise your hand right now. Nice and high, without saying anything. You just raise your hand. It's an extension of your arm, and we're not doing a deodorant check. You go all the way up. And hands up, please, when you can tell me what the answer to C. Okay, you can put your hands down. They did a quick check. Hands up, please, if you can give me the answer that we need for C. The person chosen is female. What's the probability that their favorite color is going to be blue? Sharon? No. No. Wait a minute. What did you say? 7 out of what? What was your denominator? Sorry, yes. Because there's 7 blue females and 11 total females. That is a conditional probability. If the person meets the first, then do they do this? Out of the people whose favorite color is blue, what's the probability that that person is female? Again, well, you should be able to answer this. Hands up, please, if you can tell me. Out of, oh, wait, we did. Wait a second, hang on. If we do this one, out of the people whose favorite color is blue, what's the probability that that person is female? So, who were my blue people again? Hands up, please, nice and high. What would we say the answer to that question? So, nice and high for the blues again. I'll give you 30 seconds to survey the room. What is our answer going to go through and be? All right, you can put them down now. What's the answer to D going to be? Say the answer to D would be, what are you going to say? Let me double check. If the person is female, what's the probability? How many females did we have? 13. So this here should have been 13. This would be 7 out of the 11. Because this is the probability if the person chosen is female. So this right here, if you're female, you pick the blue. Over here, this is, of the people whose favorite color is blue, what's the probability that they're female? This is the number of, let's say this, blue females. But what is it over? What is this over? Total blues. Now, again, just so we're all being honest with each other, this is one of the reasons why I only took probability and statistics once. There is a lot of conditions that are met, and as somebody who has an impulsive processor, I don't slow down well enough to go through and process these, which is why I constantly have to go back to my notes to make sure I'm doing it right and to saying it right. I expect all of you, and it's not making an excuse, but trust me, I go through, not only do we make all this stuff, but then I have to go through for this unit, I have to do all of the answers out ahead of time so I knew what they were going to do. Understand that at times, if I have an error or something that you want to see explained, you just raise your hand. One of the problems that we have is, if I put something up there that you don't know where it came from and or disagree with, we don't randomly start yelling things out, because then that creates confusion for those people trying to actually process what's going on. Now, we're going to talk today about conditional probability. What it means, conditional probability is the probability given a certain criteria is already met. The probability given a certain criteria is already met. So, our conditional probability of B is a probability that B will occur given that A has already happened. That's what the notation, and it means B given A. So it's the probability of this given that. That's how I always go through and try to remember. It's the probability of something given something else has already happened that narrows the field or is some qualifying criteria. Now, in our case, the formula for conditional probability, the probability of B given A is going to be the probability of B and A both happening, or the number of times B and A both happen, over the total number of times event A happens. It's the probability of this given that is the probability of this and that given that. Okay? It's A then B. This is always the first condition that needs to be met. This is your second one. So, for the one that we did before, we had probability of blue given female. So you've got to always take it, this given that. When you see this line, read it in your head as given. And we write this out, especially in the beginning, every time. I wrote it out every time we went through and did it the other day. Now, this is not, well, this I guess you could qualify as a two-way table. Looking at what's there, it says a sample was asked, people were asked about their favorite movie genre. Looking at what's there, we need to find the probability that someone likes comedy given they are in this range. How can we determine what that's going to be? The probability that they like comedy given that range? Well, the numerator of this, so we'll do comedy given that they're 26 and up, whatever that wedge is. That would look like the probability of comedy and 26, that band, over the probability of what? What would your denominator look like? You tell me. Go back and look if you need the definition from before. What's going down below if this is our setup so far? 3 people can tell me. Get real. What do we want to go through and say? Abby? No? You're giving me a number. I'm saying the probability of what? Yeah. No? It's going to be the 26. You're finding the probability of comedy given that they're in that 26 to 1549 wedge. So it's given that. So that's what you're dividing by. You're narrowing the overall pool down to this second grouping. So how many people like comedy and are in that wedge? How many people like comedy and are in that wedge? Robbie? Over the number in the wedge. So how many are in that band or that narrowed group? Hands up when you can answer that. 1,000. You can go through and reduce this later on. I don't really care about that. Okay? Go through right now and try the second one on your own. So as we do this next one, what is the expression going to look like? Well, I'll even say this. John Paul, read this to me. What does this mean? No? It's not the number of movies. It's the number of people that like them. Yeah?
Find the probability of 50 and over given the probability of 40.
Yeah. It's the probability that that group will, the probability of someone 50 or above, that someone is 50 or above, given they like horror movies. So, the way that we would figure this out is it's the probability of 50 and above and horror movies over what? Got the number. Over what? Yeah, the number of people who like horror movies. So looking at this, what would my numerator on this be, Christina? No? What's your numerator? No? How many people are there in the band that are over 50 and like horror? What is it, Luke? 190 over what, Luke? 680. The probability that there's 50 plus and like horror. So I go 50 plus like horror, boom. This over the total number that like horror. Now the next question is different. What's the probability that someone likes horror movies given that they're already over 50? What's the numerator on that going to look like, and then the denominator? I don't need the number. Stop telling me the number values when I say what does it look like. When I want numbers, I'll say what's the numbers. What's the setup on this going to go through and look like? Eli? Probability of what in the numerator? And horror over what? The number that we have that are 50 plus. So, looking at this, what's your numerator, Jaron, going to be? No? What's your numerator going to be? 190 over. What's your denominator going to be? What number, Cassie? Over 1,000. Why? This one is looking at a different set of criteria. The given is different. The B looks at the probability that they're over 50 given they already like horror movies versus if you finding out if you like horror movies if you're over 50 years old. They're different things. This is pulling from the group of people who say they like horror movies. This is saying how many are over 50 out of the group that likes horror movies. This is saying how many like horror movies out of the group of people who are over 50. They're different things. Take a look at question D. Company wants to sell a product. They're going to advertise. Which genre should they go through and choose? This is going to be a big kid sentence. Which genre would they go through and choose? Talia? Why? Largest probability that is liked in that age group. Same thing she said, less writing, maybe. Take a look at E. Company wants to advertise to older adults. Which genre would be the best? Or, sorry, would be the least beneficial to advertise in? So, Alex V., what are you going to say for that one? Yeah. Why? Yeah. Not exactly rocket science. Take a look. The toughest part of these, in all honesty, is interpreting what the beginning says and how to structure this. Looking at everything that's there, I'm going to use some initials to designate certain conditions. Here's a table showing the result of a new acne cream. This is the number of people whose skin improved that used the cream. Number that skin improved using the placebo. So I'm going to label this as an I for improved. This is the number of no improvement that used the cream and then that used the placebo. So this I'm going to label N for no improvement. This right here going down, how many people used cream total? How many? How many used the placebo? Take a look at what these are going to be, and yes, you have to do some reading to figure out what your setup is going to be. If a person used the cream, what's the probability that that person's skin improved? So, this is conditional. It's going to be what, then what when we do our setup. Hands up, please, if you can answer that. In this case, it's the probability of what given what. Read what's there if you don't know. Go back to another question if you don't know. It's what given what. What bar what. We got 2 people who can answer. That's not good for us. 3, 4, 5, 6, What do we want to go through and say, do you know? Improvement given that they use the cream. Now, if that's the case, I need in the numerator the probability of improving and cream over what? Hands up, please, if you can tell me what we're going to divide that by. Really? Alex, what? So what's the numerator on this going to be? Hands up, please, if you can tell me what your numerator would be. Oh. No, what do you want to say? 800. And over what? 100. Questions on that? If this, then this. Next one up. Out of the people who saw no improvement, what's the probability that they used the cream? So, what is the setup on this going to look like? Hands up, please, if you can tell me this. It's going to be what, then what, in this case, because this is conditional as well. What would we go through and set it up as? Erica, what do you think? Yeah. Cream given no improvement. So the numerator is going to be the probability of cream and no improvement all over the number of no improvements that we have. How many used the cream and got no improvement? Alexa, what do you say? Out of? $500. What's the probability that the person used the placebo and their skin improved? Now, this one is not conditional. It's direct. What's the probability? And we have something that it's going to reference that I always list out. You all tend not to in the beginning. Who wants to take a guess as to what the probability is the person used a placebo and that their skin improved? Two people. Christine, what do you want to say? Close. It's going to be 600. That meets the initial condition over what? No. How'd you get 1900? Total amount that are in there. And by the way, one of the things that I always find interesting, this actually is somewhat similar to what real results would be. This medication would get approved. Is this convincingly therapeutic? I'd say no. Looking at this, I always just look at this piece. How many people got better from the placebo? 600. Well, and this is, sorry, out of the people who, it's not as though that this is a drastic number different than this one. Looking at their skin improved. So this is the desired outcome when you take an acne. I don't want to ruin it for you. If you don't know, some people take an acne cream, and it's normally to make your skin better. It's not just to go through and get rid of lotion. Looking at this, are there drastically different results? Are there? No. Does that show the medication is useful? And the answer is no. The same thing, these numbers like this show up with things like aspirin. If you think you're going to get better, you do. Now, last one up. What's the probability that a person who used the placebo saw an improvement? Is this conditional? Is it? Reading what's there. Is it conditional? Does something need to happen? I love we're so quiet. Raise your hand for the answers. It's not like you're not going to get thrown out of the second floor here if you get it wrong. We got two people. What do you want to say? You say what? It's no what? No. I would say that it is. Here's my, and just doesn't now we're going to figure out. We say it's conditional because of looking at what's being said. Does something first need to happen before the second thing happens, or are they happening together? What has to happen first? Yes. So it's going to be improvement given, right? Is it improvement? Yeah. Improvement given placebo. So How many saw improvement given placebo? Well, that would be probability of I and B over probability of C, numbers of them. What's the probability? What would this become? I don't need you to reduce it. Hands up, please, when you can tell me what this will be. Now, looking at what's there. Questions on that? I mean, we could do some of these. These, in all honesty, I think are a little bit redundant. Take a look right now. Take a look at 4. Maybe we'll have you do some of these for homework. Looking at 4, it says a simple random sample of adults living in a suburb of a large city were selected. The age and incomes are covered. The resulting data are summarized below. It says, what's the probability that a person at random will be in that age category? So, hands up, please, when you can answer that a probability of a person chosen at random is in that age category. Tell me what you got and how you got it. We got 1 person. Read what's there. 2. I'm not asking you to do a ton of math. What would you go through and say for this one? Robbie, what do you think? What's that? Are multiple conditions being met here? Yes or no? How many conditions are there? That's 1. What is it, Amanda? Yeah. You need to find the probability of the age range over the total. And how many are in that age range? Over. Total is? What's the probability that a person chosen at random is in that category given that they have an income over 50,000? Is that conditional? Yes or no? The answer should be yes. It's what given what? Well, you tell me. It's the probability of what given what. Read what's there. Unpack the question. It's going to take some time. It's the probability of what given what. What do you want to say? The 46 band given the 50,000 income. So I need to find the probability of 46, that band, and the 50,000 over what? The probability of, or the number of 50,000s. So, how many are in both bands? Hands up, please, when you can answer that. How many are in that 46 band? Over 50,000 divided by what? What would you go through and say? Luke, go ahead. 27 over 96. Terrific. Out of those people, what is the probability that makes that amount of money? So, is this a conditional probability? Yes or no? We've got some yeses. Terrific. Then, Abby, it's going to be what? What's the setup on this one going to look like?
It's going to be the probability of 35,000.
Given. So we need to find the probability or the number of people that meet both criteria, which would be the 35 and the 46 band, all over the number in the 46 band. What is that going to go through and look like then? Hands up, please, when you can tell me. What's the answer to this going to be? Oh, my goodness. Yeah. 14 over 53, is that what we got? Yes or no? Okay. What's the probability that a person is between that and makes that? Now, is this conditional? Yes or no? It doesn't say this and that, so it's the probability that they meet both. How many meet both? 27 over what? More than that? 27 is, wait a minute, how many, what did we say the band was? What was the criteria? Was it over 50,000 and in the young band? So this one here, over what? Louder. Why is it 207? You're right. The probability of 21 and the 50,000 over all. Now, we can keep doing these, or they start to get a little bit numb. We're going to start off then and bounce over to the next question. The next day stuff, day 4. Because this stuff, actually, raise your hand if you remember doing tree diagrams before. Okay, they're so easy, so easy. And some of we screwed some of them up so terribly. Disaster. Take a look at the first one. Draw a tree diagram, represent all possible outcomes visually, and assign the probabilities to the events. First one up, draw a tree diagram that represents a coin being tossed twice. Include the probabilities, then find the probability of a head on the first toss and a head on the second toss. So let's start off with this. How many events are happening? Hands up, please, when you can answer that. This is just having a cursory understanding of the English language and reading what was there. How many? 2. Your first event is flipping the first coin. How many outcomes does that have? Jared? 2. Don't want to ruin it for you. If you flip a coin, you've got 2 options. They are heads and tails. Next one up. If you get heads on the first try, what do you do after you flip the first coin and get heads? What's the next action you would take? Hands up, please, when you can answer that. Oh, come on. I can't hear you. Yeah, it says you're flipping a second coin. I'm sorry, the same one twice. So you flip it once, and then you do that. Twice means you do it how many times? 2, yeah. So now, you flipped it once, you flip it a second time. How many outcomes are you going to have? 2. They are heads and tails. How many members of the sample space will we go through and have? Hands up, please, if you can tell me. How many elements are there in the sample space? We already did this yesterday. Yeah, 4. Now, what's the probability on a fair coin of getting heads? Hands up, please, when you can answer that. Probability on a fair coin of getting heads. What is the prop? I have no idea what a coin is. Are you going to pick one? John Paul. You don't know? You know who probably has that coin? What? Yeah. That's what they use. I didn't want to ruin it if you, like, do you play football? What do they do at the start of every football game? Now, does the home team win it like 80% of the time and the visitors like 30%? Should be 50-50, okay? Now, the probability of getting a tails end is also 1/2. Never. Does he do the coin toss? Do you really? Oh, okay. Who does the coin toss for you? I mean, don't you send delegates out like your captain or something? Changes. Oh. What's the probability of getting heads and heads? Hands up, please, if you can tell me. What's that probability then going to be? Fraction? We did our tree diagram. Not tough. Now, in the other group, did we get 2 done? Yeah. So, what I'll do is, shockingly again, maybe it's because, and I apologize if I assume too much from you. I hope and pray, like things like cards. I knew I had to go over the card things. So most people don't know the cards. But the coins you should know have how many sides of them, by the way? The coins have 2 sides, and each of them are equally weighted. One thing that you will, so what I need you all to do is this. for tonight, your job is going to be finish out pages 20, get done up to question number 3, and there's one other thing that you're going to get, and some of you start complaining, so we'll deal with it now. I'm going to give you out, now Miss Bailey's kids go through and get these and they hand them in. I can assure you, we're not handing them in because you all lie like rugs and will copy from each other like from a Xerox machine. So, instead of that, to avoid the temptation, I'm giving you all these questions now. Anticipate I'd have it done by Friday of next week, which is going to be the 7th, or Thursday, whichever one, the last day of the week that we meet. Maybe there's going to be a graded quiz on these questions and or like something profoundly similar. So, maybe. Who knows? There's something in my eye, excuse me. No, there must be some sort of dander in my eye.